Good afternoon, everyone. Today, I'd like to continue to present the system contract of Zksync, one of my favorite L2 blockchain. So last time we talked about the system contract MSG value simulator, which is used to forward Ethereum to the callee when the caller want to call a payable function. So today we are going to talk about the L2BaseToken, which is used to manage Ethereum representation on L2. So it's a managing Ether, okay, on the L2. So so let's look at the source code. As you can see over here, this is L2BaseToken. It's just very straightforward contract. First of all, the first function is transfer from two, which is used to transfer Ethereum from one user to another. You don't call this function by a regular user. It's only used by three system contract, MSG value system contract we talked about last time, which is used to forward the Ethereum from the caller to the callee. The second one is deployer system contract. We imagine when you deploy a contract, you can also, as a part of the constructor call, you can also send Ethereum as well. So we will go over this when we talk about deploy system contract. Maybe that's the contract we should look at next time. And then the bullet loader formal address, which is very fundamental contract. This is probably the contract we're going to look at the last time in the last step. So it's just standard, debit and credit operation over here. The contract manages the balance of all the users, including systems, Ether balance. And this is only L2. So, and then you are doing the transfer over here. So, so you can also use a call balance of. I think many of these is a little bit similar to ERC20, but I don't think like there's a transfer or other kind of thing. But there's a mint and there's also burn. So mint is over here, and then where's the burn? Oh, okay, here's the burn. So burn is going to, based on the NSG value, is going to bring it. But today we are going to look at the withdraw message as well. In particular, the withdraw is we talk about how the withdraw is done in L1, but actually it's initiated on L2, right? The withdraw is really initiated on L2 first, and then continued on L1. So this is where it's the entry point. Anybody can call this function. It can be called by a user. So that and then you send, when you call this function, you send along with the Ether, and that Ether will be burned. And then a message will be sent to L1. So here's how you create a message for L1 over here. You just simply, you just encode the finalize Ether withdrawal with the recipient on L1 and the amount of Ether you want to send to the recipient on L1. And then once you create that message, you're going to call the L1 messenger contract, another system contract, which we are going to talk another day, but let's go over a little bit first, which is right here. I put this yellow because this is the one who is going to use the two immediate event, which is going to be used by relayer to call L1. So you can consider this is like the contact the contract for L1. Okay, so so once you do that, then we are going to call the L1 messenger contract sent to L1, which is right here. Right here first. Over here, this one. So the input is simply a bytes, a message. And then what it's going to do is going to calculate the hash of a message. And of course, you're going to remember the gas fee to to call the kickcat function. And then you're able to calculate the chain message hash. This is a accumulated hash. So you can see using the previous chain hash with the new hash, and then you concatenate them, and then you calculate new hash. So this is the accumulated one. It's going to ensure the integrity of the whole batch. So, and this is going to be cleaned by every time when you the when the whole batch is published on L1. Okay, and then over here we're going to construct on L1 to L2 log with a few parameters. This is all the 0 to 2 right now for the moment, and then we're going to put the send over here. In this case, it's going to be L2BaseToken. Oh, I'm sorry, it's going to be L1 messenger. It's going to be the sender for this log. And then we are going to also convert the key to be the message sender. In this case, it's L2 base token, and then the hash of the message. And then we have a process L2 to L1 log. This is basically log. You can consider log is a little longer than message itself, containing the context information. So the process L2 to L1 log is going to calculate the hash of the log, a lot of log value. You can check if all the fields are already included. And then there's also a chained log hash similar to chained message hash, which is cumulative. And then you're going to return an ID for the log. So the ID of the log is the number of logs to process. So that becomes the ID over here. The ID is retrieved first, and then we increase this. So you can imagine this ID. I think it should start from 0 because you retrieve first before you increase. And then we are going to emit this. So we talk about that you cannot talk to L1 directly. So all you can do is emit an event, and then this event contains all the information we want. And then the relayer is going to pick up the event and then call L1 and then publish all these. I think that is the hash of this local root hash on L1, so people can verify that a message is included when we withdraw, and then the status and so on. Okay, so that's the first event. It's going to emit it, and then the next event is once we are done over here, is we are going to calculate the public data length, which is you can consider this is the size of all the bytes you want to publish on L1. So we need to calculate the gas you have to pay. This is a long formula. So this formula includes all the kicker hash computation we have done in this particular function, as well as the function that is going to be called later, not now, but the relayer is going to, I guess the relayer is going to call this function right here, called publish pub data and the clear state. And then this will also burn gas. So this gas burn, this function is called for the whole batch. So the gas used in this function is going to be shared by every single message and every single log. So we can, I think this is called amortized. So the amortized gas cost is going to be included in this formula as well. So once that's done, then we're going to emit L1 message center. So this is second emit we can consider. And then so that's the second emit. Then the third emit is right here, withdraw. We're going to put it, okay. But I think in order for things to see a little bit better, I actually changed L2BaseToken so a little bit. So before withdraw, I print out something using header and then print out how much is withdraw, how much is main. So in addition, I also put an additional emitter called a look over here. I call this as a 2. This is emitter 1. So I know I can tell which event is emitted. So that's a little bit, debugging skill over here to make things a little more clear. Okay, so this is the third event, and once third event is done, then the user's Ethereum's balance should be decreased, and then later on L2, somebody is going to a relayer is going to call, and then a user can withdraw their Ethereum on L2 based on the message sent from, on L1 based on the message sent from L2. Okay, and one more thing I'd like to show is before I start our experiment a little bit is over here. I reserve an interesting. Sorry, I also do similar debugging for this one. So which is right here. As you can see here, when the MSG value is simulated, I try to print out what is the MSG value, who is the real callee, and then what is the mask, including system call mask over here. Are we forwarding a system call, or are we forwarding just a user call? And then in addition, over here is trying to set the NSG value context using this method, and then we call the member call. And then interestingly, I found out if I do a debug over here, I will get into trouble. Why? Because this is going to set the NSG value for the next call. So if I have another call over here, then by the time I call the member call, the context is already compromised, already damaged by this inserted log method. Okay, and I discovered that if I input this to console, then the callee is going to receive, the NSG value is going to be equal to 0 rather than the real value. So this is an interesting discovery. So why don't we try to call over here? Why don't we do withdraw by reach? So let me add the only over here. So this is the, I will get rid of this. And then let's run this. This is okay. So this is the this is the testnet log. So we can run this and see how withdrawal happens. Okay, by looking at all the console log and the event emit. Okay, so withdrawal is done. I think this is a before withdrawal, this balance, and after withdrawal is this. What is the amount of withdrawal I'm doing over here? Let's just double check withdrawal. I make it a lot of 1 over here because this is a binary. So let's. Well, actually, this is hexadecimal. So the reason I use a hexadecimal over here is in the debugging they print out a hexadecimal. So I think it's a little bit more clear that I can see how the withdrawal happens. Okay, so let's look at for the withdrawal printout. It's okay. It's right here. It's right over here. As you can see, the function is starting from from here. It's starting from here. So as you can see, it's going to call the MSG value simulator first because the withdraw function is a payable. You are using the payable MSG value to send to the callee. In this case, is the L2BaseToken. And then so the base token is going to do a transfer. This is a lot of 1 over here in hexadecimal. So now it's going to send it to this is the address of the callee, which is L2BaseToken, the contract we talk about. And then I think eventually they're going to return some gas fee back to the user. So this is the rich wallet, the user. And then from the event, we can also see, so this is the transfer, signature, DDF2 is transfer signature, doing this transfer. And then this is a return the gas, I believe, transfer back. This is from to this. And then the next one is transfer, also doing transfer from the user to the 800A is the L2 node driver. Okay, so in other words, let me just make it. So the first one is pay the gas. The second one is gas refund. The third one is transfer the MSG value. But this is actually by the MSG value simulator. And then we have 3 events. The first event is by L1 messenger sender. This is the L2 to L1 log sent event. And then, oh no, I think, yes. And then this is let me just look at this so you guys see better. So this is the second event. This is the first event. This is a second event, and then this is a third event, which is really corresponding. We can see over here. So L1, this 27FE is 27FE is the L2 to L1 log sent. So there's only nothing is indexed, so there's only data and then just the signature, okay, which is one word. The first, this is topic 0, okay, and then L1 messenger is topic 0 is 3A36 is L1 message sent, and then there are 2 indexed topic. Topic 1 is the topic 1 is the caller, is the caller, which is L2BaseToken, and then the next one, just took a look at this. Next one is it's the hash, okay, and then the third one is the message, which is not indexed. So this is that. So this is the hash of the message, hash of the message, and then this is the whole message data. Okay. All right, and then this is the included look event I put over here. I put over here for the withdraw. This is a look event 002 in particular, so we can verify it's 002. And then the event of withdraw. So this is a 2717 with withdraw, and then from and to, if that's the case. Yes, it's this is a from and this is a to. Both of them are the same, and the amount is a lot of one over here. Okay, and then finally, what is this? Yeah, finally they also return, I guess, a little bit gas over here back to the user. So so that's very much of it. So thank you so much. Have a nice day. I do see one thing over here. I want to see that this 3 is probably the part belong to MSG's value simulator. So look like it's a separate gas pay and the gas return over here. And then it's almost like two transactions. One is calling the MSG value simulator, which you pay the gas, you return the gas, and then transfer this, and then the next one is doing another return over here. So at least there's C2 return of gas transfer. This is the second return, and this is the first return. Okay, something that is interesting. Okay, so thank you so much. Have a nice day.